Hello, good morning, everyone. Good morning to our mentor and teacher, Muhammad Isad Alam, and good morning to all my classmates as well. Thank you, sir, for giving me this opportunity to present myself on the topic of design of saddle support for horizontal pressure vessel. This has been the great opportunity, and I would like to thank Mr. Muhammad Isad Alam and all my classmates, and I would like to extend my gratitude to my institute, Muzaffarpur Institute of Technology, eh, Department of Mechanical Engineering. So, I will start my discussion over the topic of the design of saddle support for horizontal pressure vessel. Some of the things that will be discussed in this presentation has been enumerated here. Introduction. First of all, introduction about the horizontal pressure vessel and its research scheme will be given here, and various dimensions needed for this project will be discussed. Research scheme will also be there, and its result and discussions will be done, and then after, ultimately, conclusion will also be discussed. Here, this is the introduction. So first of all, we need to understand what is horizontal pressure vessel. Pressure vessels are the mechanical equipment which are used to store liquid, vapor, steam, etc. at a very high pressure and temperature. So pressure vessels are subjected to very high thermal load. So accordingly, we have to design the saddle support for the horizontal pressure vessel. The purpose of our research is to design the saddle support, not the pressure vessel. Pressure vessel will be designed separately, but here the presentation is for the design of the saddle support for the horizontal pressure vessel. So I will try to keep myself on the design of the saddle support only. We will not discuss anything about the horizontal pressure vessel design, but some of the introduction about the pressure vessel will be given here. So please listen to carefully. All the important points has been provided in this introduction, like into industrial horizontal pressure vessels are general structures having complex geometry. Sometimes we think that horizontal pressure vessel means it's a simply vessel, but it is not a simple vessel. So much complexity is there inside the pressure vessel. Geometrical complexity, you will find that so many stress concentration points are also there that we need to consider, as this has been given in the slide, that comprising of various geometrical discontinuities and are commonly required to work under high loading conditions like external forces, thermal loads, internal pressure. So the most important factor to consider in the design of the horizontal pressure vessel will be the thermal loads. Then after comes internal pressures and all other external forces also. And the second point is the designing and manufacturing of such products are done by the guidelines and codes as per the international standards. So here I would like to tell you that the designing of the horizontal pressure vessel and its saddle support will not be done as per my choice, but it will be done as per the international guidelines. So which are the authority giving the international guidelines, that we need to understand. So this authority, international authority, which will give us the international guidelines to follow while designing in horizontal pressure vessels are ASME, Pressure Vessel Code Section 8, ASME, Pressure Vessel Code of Section 8 of ASME will be followed during the designing of the horizontal pressure vessels, and European Committee for Standardization and British Standard Institutions code will also be followed. And the fourth point that we would like to discuss is horizontally kept pressure vessels are generally supported on twin saddle support. So twin saddle support, its main function will be discussed, its main importance. Sorry for the interruption. We will come to the next slide. So these are some of the dimensions which has been shown in this slide, and you can see here from the side figure that twin saddle support has been shown, and horizontal pressure has also been shown. This model has been designed on ANSYS software. ANSYS software mesh analysis design has been shown here, and main dimensions. So we do not need to go in depth in deep detail of this dimension, because this is simply for the presentation point of view. So next slide comes research scheme. Research scheme means what are the scheme that we need to consider, that we need to evaluate after our research, our project is completed. So first of all, what we will do, we will prepare a mesh analysis of the horizontal pressure and twin saddle support in the ANSYS software, and some mathematical formulation will also be done. And using mathematical formulation and considering horizontal pressure vessel as a simply supported beam, stresses acting at various points will be calculated, and using ANSYS software, stresses at various points will also be calculated. So both of these values will be compared thereafter, and after comparing these two values, we will be able to reach at a conclusion that which method is most suitable for the designing of the horizontal pressure vessel. Either it is ANSYS software analysis, or it is simply mathematical formulation. But obviously we know that simple mathematical formulations are ideal schemes, and the value calculated by mathematical formulations will not be exact. This value will be approximate value, but the exact value will be calculated using ANSYS softwares. So later in the discussion and in the result slides, these things will be discussed later. Okay, next, these are some of the graphs regarding regarding horizontal pressure vessel, and its practical things has been shown here. Now we come to the conclusion. Comparative study of the stress obtained by ANSYS software and mathematical approach shows that stress calculated by ANSYS is less than by mathematical approach, also less than by allowable stress. Hence, it has been found that the present design is safe. The stresses in the vessel and shadow support at different locations. So after doing all this research and all this presentation, we come at a conclusion that the value found out using ANSYS software was less than the calculated value. Hence, we come at a conclusion that the value calculated using ANSYS software is even less than the allowable stress, and hence our design is safe. For doing this research, some of the bibliography was also referred, like ASME Boiler and Pressure Vessel Code Section 8 was used while considering international guidelines over the design of the horizontal pressure vessel twin saddle support. And also some of the research paper was referred during research, like A.L.S. Ong and Lu research on the optimal support radius of loose fitting saddle, and Abbasi and Maguire research over three-dimensional finite element analysis saddle support pressure vessels. So all these are bibliography or the references which had been preferred during the preparation of this project. So this is the bibliography. This much is for this research. If anyone has any doubt, please raise your hand. I will try to clear doubt as much as possible. Okay, thank you.